Hello friends, I welcome you to the video solutions of JEE Main 2019. Now we are taking the paper of 12th January evening session. Let's start with our first question. Now here the very first question belongs to a section of modern physics of chapter semiconductor, right? Now in this particular question, what is given is, in the given figure, VBB, the supply, can vary from 0 to 5 volts. VCC, that is this battery, is having 5 volts of potential. The current gain is 200 and input resistance is 100 kilo ohm and output resistance is 1 kilo ohm. We have the output of 1 volt at this point of time in the input zone. The minimum base current and the input voltage at which the transmitter will go to saturation will be. So I have to find the base current as well as the value of VBB, which will be appropriate for this case. Let's start with the solution. As you are very well aware of the equations, in this case, when you see this output zone, you will write VCC minus the drop against this, that is ICRC, should be equal to 0. So, I'll write VCC minus ICRC, that should be 0. Now, we are well aware from this fact that VCC is given to be 5 volt. And RC is given to be 1 kilo ohm, right? From this I will get IC as 5 milliampere, right? And the current gain is given to be 200. So you are well aware that beta is equals to output current by input current. Here input current is IB and this is given to be 200. Solving this, you will get delta IB is equals to 2.5 into 10 to power minus 5 ampere, right? Or I can also write 25 microampere. This is the base current I have. Now let's talk about the value of VBB. So if you have this supply here, so VBB minus IBRB should be equal to VBE. So on solving this, VBB minus IB RB should be equal to VBE, right? Now, we don't know the value of VBB yet, but for IB we know this is 2.5 into 10 to power minus 5. What is the value of RB? 100 into 10 to power 3 ohm. That should be equal to value of VB, which is equals to 1 volt. On solving this, you will get VBB is equals to 3.5 volts, right? So, we have the value of IB and VB as well. Let's see which is the best suited option. So on the 4 given options, answer number 1 is the right option to this question, right? Let's move ahead and see our next question. Now the question you see here belongs to a section of heat and thermodynamics. Now as per question, there is a vertical closed cylinder which is separated into 2 parts with a frictionless piston there, right? The upper part is of length L1 and the lower part is of length L2, where L1 is greater than that of L2. Both the sections contain same number of moles at same temperature. We want to calculate the mass of that piston, and that piston is frictionless, let me tell you. Let's see how we can solve that. So first of all, let's have a diagram which will specify. So this being the chamber, right? Here is that frictionless piston we are talking about, right? This section is L1, this section is L2. Both are having same number of molecules. The weight of this piston will be downwards. Suppose here is pressure P2 and here is pressure P1, right? The area above is A. Now, due to the difference of pressure, the pressure P2 should be greater than P1 so that it can push the piston up, and P1 and mg together will push the piston down, as P1 will exert some force on the piston downwards. So from here I will say that mg would be equal to force exerted by pressure. So that would be P2 minus P1 into area. Now for P2 I can write nRT by V2 minus nRT by V1, right? This would be mg. On solving this, you know that V2 can be written as A into L2 and V1 would be A into L1. So from here, just put down the values and you will get mg is equals to nRT by L2 minus nRT by L1. Solving this, you will get nRT by G L1 minus L2 by L1 L2. Let's see which is the best suited option here. So among the 4 options given, option 1 is the right answer to this question. Clear? Let's move on to our next question. Now this question belongs to a section of current electricity, that is electromagnetism, right? As per the question, the galvanometer is there which is having a resistance of 50 ohms. So capital G is given to us as 50 ohms. It has 25 divisions in it, and when current of 4 into 10 to the power minus 4 ampere is passed through it, it produces a deflection of 1 division. That is, we have to calculate the maximum deviation current, that would be 25 into 4, right? That is 10 to the power minus 2 ampere. So if we want to make this galvanometer or convert this galvanometer into voltmeter of 2.5 volt range, then what should be the value of resistance that should be connected? For this, it's a very simple formula. So let's start with the solution. What we need here, friends, is R, which is simply given by V by Ig, that is the galvanometer current, minus G. This galvanometer current will be the current which produces full scale deflection. So this is 25 into 4 into 10 to the power minus 4. This would be simply 10 to the power minus 2 ampere. Right? What is the value of G given? G is 50. Right? What is the value of potential we want? The maximum potential would be 2.5 volt. So R would be 2.5 divided by 10 to the power minus 2 minus 50, and this would be 200 ohms. Right? Let's see which is the best suited option here. So among the 4 options given, option number 3 is the right answer to this question. Hope this was clear to you. Let's move ahead and see question number 4.